Hey everyone, I'm back with another problem on the InterviewBit series on the topic arrays. So this problem is called pick from both sides. Okay, so let's read the problem first. So you're given an integer array A of size n. You have to pick exactly B elements from either the left or the right end of the array to get the maximum sum. Find and return this maximum possible sum. You have a note. You can pick the first four elements or can pick the last four elements or can pick one from the front, three from the back if you have array of size 10. Okay. All right. So these are the constraints. So n is less than or equal to 10 to the power 5. Let's move on. All right. Let's take this example. Okay. So we have 5, -2, 3, 1 and 2 and we have to pick 3 elements from the array and we need to return the maximum sum. The condition is we can pick elements from left or the right end. Okay, so we have to pick the elements from end and continue picking from towards the ends to the center. All right. So you have quite a few possible combinations here, right? So I can pick all the three elements from here, or I can pick all the three elements from here, or I can pick two elements from here, one element from here, and so on. So there would be multiple combinations in this case, right? So let's just try to print all the combinations and see which fetches us the maximum sum. Okay, right? So this will show me how many elements I'm going to choose from left and this from the right. Okay, and b is equal to 3, so we have to choose three elements. So the first case would be I'll choose all the three from left and none from right. So in this case my answer is going to be 5 plus -2 plus 3, which is 6. Perfect. The next case is I'll choose one element, two elements from left and one element from right. So in this case my answer is going to be 5 plus -2 plus 2. In this case, the total sum is going to be 5. The next combination is I'll choose only one element from the left and two elements from the right. So in this case, my answer is going to be one element from the left, two elements from the right. In this case, the sum is going to be 8. Perfect. And if I choose no element from the left and all the three from the right, in that case, my answer is going to be 3, 1, 2, which is equal to 6 again. What is the maximum sum which we are getting here, right? This is 8, and so our answer is 8. Perfect. So this is a pretty straightforward implementation problem. So how do we approach this, right? So the first idea is we can preserve all the elements from the left in a variable sum. So sum contains all the values, all the b values from the left. Okay, so in this case the sum initially would be 6. Perfect. Now we'll iterate from right. Okay, till now we'll try to iterate from right for all the three elements. Okay, and we'll start decreasing from the left end. Perfect. So for the first case my current sum is 6. Okay, so 6, what I'll do is I'll try to add this element from the right. Okay, I'll try to add this element from the right, which is +2, and I'll remove the element from the left. Remember to remove from here. Okay, that's it. That's it. Perfect. So -3. So in this case my sum is going to be 5. Perfect. Now my current sum is 5. So now in the next iteration I would be adding this element to my answer, +5. And what I'll subtract this element from my answer, minus of -2, which is equal to 5 plus 6. This happens to be 8. Perfect. Now my current sum is 8. Okay. Now I'll try to include this element to my answer. Perfect. 8 plus 3 and minus I'll finally remove the first element from the left, which is 8 plus 3, 11 minus 5, 6. Perfect. Right. So in this case, we are picking all the elements from left and none from right. In this case, 2 from left, 1 from right, 1 from left, 2 from right, and none from left, and all the 3 from right. Okay, got it. And the maximum sum possible is 8. So this is going to be our answer. Okay, pretty straightforward problem. So the time complexity is, since we are traversing the array in a linear fashion, the time complexity for this question is big O of n, and the space complexity is of course a constant space, which is O of 1. Okay, now let's move on to the coding part. Okay, now let's code it up real quick. So we are given an array and integer b. Okay, so the size of the array would be n, would be a dot size. Now let's first just maintain a variable called sum. Okay, now let's take all the elements from the left first and store it into the sum. So we'll pick all the first b elements from the left and store it into the sum. Okay, right. So now sum contains all the b elements from the left and none from the right. Okay, perfect. Now I'll say the maximum sum which we have, I'll assign it to the sum which we currently have. Perfect. Now I'll maintain a pointer called left, and it will be pointing to the last index of the current subarray which we have taken as our sum. Right. Okay. Now we'll start from right, and we'll start from the last element, and we'll pick elements from the right end, and we'll iterate till we reach all the elements, all the b elements from the right, which is equal to n minus 1 minus b. So we'll start from the right element, and we'll go until we have picked all the b elements, and we'll do a right minus minus, and sum is equals to sum plus, we'll take the right element and we'll subtract the left element. Okay, this is how we are going to do it. And of course, you move the left pointer, you'll move the left pointer, and at every step you are going to assign the maxi is equals to max of maxi comma sum. At the end you return maxi. That's it. Let's just run it. Okay, so the trivial cases are passed. Let's submit it. Yeah, so it is accepted. So it was a pretty straightforward problem with a pretty simple implementation. I hope you guys understood it. We'll meet in the next video. Till then, take care. Okay, chalo, bye.